Hi, my name is Coach Davis, for those of you that don't have me as a teacher. This week in physics, we are starting with electricity. For the remainder of the year, we will be talking about electricity in some form or fashion. Today, we're going to be looking at the two PowerPoints that I sent out. One's called electric charge, the other one is called Coulombs Law. At the end of both of those, I put some word problems on there and didn't put how to do them. I figured me typing a bunch of stuff on there, you still wouldn't quite understand what to do. So I thought I'd do a video and work you through the math problems through the video. So before we start on those problems though, there's a couple of things I need to point out. One is that one electron is equal to negative 1.602 times 10 to the negative 19 coulombs. Can't see all that, there we go. So every time it's talking about electron, the charge for one electron is always going to be negative 1.602 times 10 to the negative 19 coulombs. Now, you cannot have a partial electron. So you can't have 0.5 electrons. Even if we're talking about bigger than 1, you can't have 13.5 electrons. You can only have whole electrons. You can't have partial, can't be less, has to be whole. So we could have like 5 million electrons, we can have 100 electrons, whatever the case may be, and try and figure out the charge for it, but we can't have anything like 13.5. Right? The other thing we need to talk about is protons, in case there comes up to a question about protons. Protons are going to be the same charge as an electron, but it's going to be, think about it, a proton's what to an electron? If you said positive, you are correct. So the charge is going to be positive. So your charge for that proton or any proton is going to be positive 1.602 times 10 to the negative 19 coulombs. So if it asks you to calculate the charge for 15 protons, you're still going to use the charge of the positive 1.602 times 10 to the negative 19 coulombs. I'll work you through that math in just a minute. Now, I'm saying this word coulombs. That's the unit for charge. Every time you have a charge, you're talking about coulombs. Now, I just put a C because I just want to write a C. I don't want to write the whole word out there. I know a lot of my students like to write and write and write, and they don't mind writing the long word for coulombs for their unit. Right? So, but it looks like this. Right? That's coulombs. You do not have to write out the word coulombs. You can just put the C. Right? The other thing I want to point out is micro. A micro looks like that. So microcoulomb. That unit right there, that micro, is also called a mu, MU. Kind of looks like an MU a little bit. Right? So that's a micro. So microcoulomb, we can't have a microcoulomb. We have to convert. Right? So when we convert, it's going to be okay. Got this. Every time you see that, it's going to be times 10 to the negative 6 every time. Right? So if I have 7 microcoulombs, then all I have to do to put that into coulombs is say 7 times 10 to the negative 6 coulombs. Right? So every time you see this, you're going to do the times 10 to the negative 6. Right? Now, I'm going to erase this and we'll get into our first problem on the electric charge PowerPoint. So the first problem states, what is the charge of an object that gains 1.2 times 10 to the 8th electrons? So we know we have 1.2 times 10 to the 8th electrons. And that's it. That's all they told us. 1.2 times 10 to the 8th electrons. Nothing else. What in the world? We can't do that math. Can't do anything with just one number. I guess we got to move on. All right, question 2. All right, so we got our electron here. It told us that we want the charge. We got to figure out the charge for this electron. So it's a conversion problem. I know, I said conversion. It'll be all right. So 1 goes underneath here. Like this. Multiplication. Now, over here, we want to get rid of this electron because we said that we're looking for the charge. Since we're looking for the charge, we want to get rid of electron. We want the coulombs as our unit. Right? So we want to get rid of the E for electrons and convert it into our coulombs. So now, if I want to get rid of this E, I got to put my E down here. Well, you remember just a second ago, I told you that one electron is going to be equal to, every time, negative 1.602 times 10 to the negative 19 coulombs. You're going to need these numbers for all these problems, right? You're always going to use the negative 1.602 times 10 to the negative 19 coulombs every time. Just our order is going to change, and you'll see that in the second problem. But our electrons cancel out. That's going to leave us with our coulombs. So now all we have to do is our math. Well, this one's pretty easy. The numbers are on top. So all we have to do is multiply these two numbers right here, and we'll have our answer, and we can move on. So 1.2 times 10 to the 8th times negative 1.602 times 10 to the negative 19 coulombs is equal to negative 1.92 times 10 to the negative 11 coulombs. I just had to multiply the top, and I was done. So that's our answer to our first example. I'm going to erase that and get to our second example. All right, so the second one says, how many electrons are gained or lost if an object has a charge of 4.6 times 10 to the negative 6 coulombs? All right, so the number they give us is 4.6 times 10 to the 6 coulombs. Now, it's going to be just like what we did. It's going to be a conversion problem. So over 1. This time it started with the charge, and it wants to know how many electrons were lost or gained in this. So now when we do it, my coulombs, am I still going to keep my negative 1.602 times 10 to the negative 19 coulombs at the top? No, because then they wouldn't cancel out. So I have to put my negative 1.602 times 10 to the negative 19 coulombs down at the bottom. We put my 1 electron at the top. Now, my C's, my coulombs, are going to cancel out, leaving me with electrons when it's all said and done. This time, however, I can't just multiply across and am done in one step, unfortunately. I'm going to take 4.6 times 10 to the 6 times 1, get my answer for that, which is 4.6 times 10 to the 6, over 1 times negative 1.602 times 10 to the negative 19. So when I multiply that, that gives me my negative 1.602 times 10 to the negative 19. Oh, I left my E off up here. Sorry about that. So now I can divide and be done. So I divide those two numbers. When I divide those two numbers, I get negative 2.87 times 10 to the negative 13 electrons. You can see all that. There you go. So I just multiplied my top, multiplied my bottom, put both of my answers here, divide, and get my answer. Now, the other part of the question asked, are they gained or lost? I'm going to give you 2 hints to look at here. The first is right at the beginning with the charge. The charge was a positive 4.6 times 10 to the 6. So it was a positive 4.6 times 10 to the 6th power. So since it was positive charge, that means I have more protons than electrons. If I have more protons than electrons, that means that I lost electrons. The other thing is, right here, this is my number of electrons. So if my number of electrons is negative, that means I lost these electrons. Right? So this is a lost electrons. Right? So if it was that I gained electrons, then my charge up here would have been negative. My answer here would have been a positive number. Right? Again, this one is for loss of electrons. Okay, I'm going to erase this one and do our last problem. Our last problem is on the second PowerPoint for Coulombs Law. Before I get into the actual question though, I want to talk about the different parts for Coulombs law. Coulombs law is this right here. So it is Fe equals Kc times Q1 times Q2 over R squared. The Kc, that C is a subscript. Now, my kiddos, this R, as we've talked about before, right? They used to use R all the time for radius and the distance in between and stuff like that. But the distance in between nowadays, a lot of people are using a D instead. So you can use a D or you can use an R. It depends on what source you're looking at as to if they use an R or a D. So don't be confused by that. You can do an R or a D here. It doesn't matter. It's the same thing, right? It means distance. So either way you want to go about doing it. And what I put in the PowerPoint, I put the old school R, right? Now, the FE, what does the FE mean? Ooh, I may not put the F and the E together in one letter. All right, so the F and the E, that means electric force. An electric force, all forces, remember, all forces doesn't mean if we're talking about force, electric force, normal force, any force that we're talking about is always the unit of Newton. Right, so that unit is Newton. Kc means Coulombs constant. Okay. So Coulombs constant, that number is going to be constant. It's always going to be this number I'm about to give you. It will not change no matter what you're doing. Right? And that is going to be 9 times 10 to the 9th power. Every time you do these problems, the Kc portion of these problems is going to be 9 times 10 to the 9th. Every time. Q1 means charge 1. Q2 means charge 2. Those units are coulombs, just like what we talked about. Right? And the R is our distance. And that unit is meters. All right. So there you go on that before we get started. And again, Q1 and Q2 is charge. The unit for that is coulomb. Now, for the problem that I have on the Coulombs Law PowerPoint. All right, so Coulombs Law PowerPoint. The question says, a 6 Coulomb charge is 8 millimeters away from a 12 Coulomb charge. Find the force between them. So we are looking for the FE. Oops, you cannot see that, can you? So we're looking for the force. So find the force between them. So we're looking for the force. Kc is always going to be 9 times 10 to the 9th. Our Q1 is 6 coulombs. Our Q2 was 12 coulombs. And our distance between them is 8 millimeters. Now, I think we might have a red flag. It says 8 millimeters. I think I just told you that the R had to be in meters, right? Yeah, so that means we have to do our conversion. So millimeters to meters, that takes us to 0.008 meters. All right, we do our conversion over from milli to our meter, and that is 3 places. So that's where I was right here with my decimal. I went 1, 2, 3, put my decimal, filled in with zeros, and that's where I got my 0.008 meters. Right? So to do this, I have to use 0.008 meters. Right? I ran out of whiteboard, so I'm going to erase right now. to do my math. All right, a little big, just a little bit. All right, so to do this math, I have to plug into my formula. So my formula is FE equals KC Q1 times Q2 over R squared. I plug in. I'm looking for the FE, so I'm going to leave the FE as FE. My KC every single time is going to be 9 times 10 to the 9th. Every time. Every time. Q1 for this problem was 6. And my Q2 for this problem was 12. So 6 times 12 over. Now my R, don't forget this R we just converted. So it's not the 8 millimeters anymore. It's the 0.008. And the number one thing that people forget about, and my kids did this year as well. Y'all did remember when we talked about our gravitational and the bottom number is supposed to be squared. There's a lot of times y'all did the right math. You just forgot to square the bottom number. Don't forget to square this right here. Right? So 0.008 squared. Right? Do not leave off that squared. You will not get the right answer without it. Don't forget it. Okay? So now all I have to do is plug it into my calculator as is. I do 9 times 10 to the 9th times 6 times 12 divided by 0.008 squared. Okay? When you plug that in, you will get your force of 1.01 times 10 to the 6th newtons. Oop, not the 6th, the 16th. I can't read my paper over there. My bad. All right. So 1.01 times 10 to the 16th newtons. Okay. All right. So you just plug that in and there you are. Remember, every time your unit for force is newtons. Okay. I'm going to erase that. Let's scoot that over that way for a second. All right. So that is our electric charge and our Coulombs Law. If you have any questions on that, you can visit with either me or your physics teacher during their Zoom time. My kiddos, on Tuesday, I can go over this some more and work it out some more with you one-on-one on our Tuesday from 12 to 12:30 class that I'm doing. I can work some more math and go through that with y'all and answer any questions that might have come up in the middle of this video that you had. So let me know on Tuesday what your questions are, and we can go over it and get more clarification that we need. But if this was great for you, then great. I'm glad the video was good for you. Again, if you have any questions, let us know. We're there for you. And y'all take care. Bye.